In this section, we'll explore the table presentation of continuous or grouped data. By that, we really mean any quantitative data that are continuous with no gaps in between values, or for data that can be grouped into continuous range. We will begin with the what and the why and the key terms of frequency distribution before proceeding to transform raw data into frequency distribution, relative frequency, cumulative frequency, and cumulative relative frequency. What is frequency distribution? Well, it is a table that divides the data value into classes and then shows the number of observations in each class. Very similar to frequency table we encountered earlier for discrete data, except that the data is now divided into classes or groups and not into discrete categories. The purpose is to condense the data so that they can be easily understood. Again, this is similar to frequency table. The only difference is that frequency distribution is used when we have a large set of data with many different data points instead of a few repeated values. And the data can be grouped meaningfully into continuous classes. Some key terms that we should familiarize ourselves with are as follows. A class means each category or group of the frequency distribution. Frequency, as we know it, is the number of observations in each class. The class limits means the boundary of each class, where the lower class limit is equal to the smallest value in the class, and the upper class limit is equal to the largest value in the class. Class interval means the width of each class, or how wide the interval is. It is preferably a round number W taken to be the number that is greater than the largest value in the raw data minus the smallest value in the raw data divided by the number of classes desired. Finally, a class mark is the midpoint of lower and upper class limit, which is taken to be equal to the lower class limit plus the upper class limit divided by 2. Some guidelines for frequency distribution are that 1. Classes are mutually exclusive. A given data can fall into only one category, and there should not be any overlapping of classes. So we cannot have a class of 15 to 20 and a class of 20 to 25 at the same time, since there's an overlapping number of 20 that falls into two different classes. This other case is also not allowed, since there is an overlap between 30.2 and 30.5. The second guideline is that the classes must be exhaustive, meaning that all data must be included in the range, and no data should fall outside the range. Lastly, the classes can be open-ended, but we should try to avoid it. So it is possible to have a class that has no lower limit or no upper limit, such as 80.0 cm or more. However, we should try to avoid it as much as possible unless we have a situation where a few data values are either very high or very low compared to others. For continuous data, there are some additional steps involved when constructing the frequency distribution, since we need to group the data into classes. Step 1. We need to decide on the desired number of classes. Ideally, the number of classes should be between 5 to 10 so as to make meaningful comparison. Step 2. Determine the width, W, of each class by taking the largest value in the raw data minus the smallest value in the raw data divided by the number of classes desired. Then round the number up to the next whole number. Step 3. Based on the width found in Step 2, we now decide on suitable lower and upper class limit for each class. Finally, Step 4. Count the frequency or the number of observations that fall into each class. In the next section, we'll run through these steps in greater details.